Greetings, parasite ecologists. Welcome to our last video on the monogenea. In the previous videos, we talked about how the monogenes have extreme host specificity and how amazing they are at tracking their hosts through the environment, which is probably something that they had to get amazing at, given that for many monogene species, their entire fate depends upon just a single species of host. And now, I want to talk about one more thing that makes the monogenes special. They help to illustrate really well the difference between microparasites and macroparasites. Remember back to one of our early videos when we went over the terminology in this video series. And remember back also to the papers that you read at the time, Bush et al. 1997 and Lafferty and Kuris 2002. Remember that we defined the terms in this way. A macroparasite is a parasite with intensity-dependent pathology. And a microparasite is a parasite with intensity-independent pathology. What do I mean by intensity-dependent pathology? Well, imagine that you're colonized by a single parasite. Is the fitness cost less than it would be if you were colonized by many parasites of that same species? If your answer is yes, you're dealing with a macroparasite because the pathology that you are suffering from is dependent on the intensity of infection. More parasites, more problems. If the answer is no, then you're dealing with a microparasite because the pathology that you're suffering doesn't depend on the number of parasites that colonized you. This can be a confusing concept for many people because, in general, physically small parasites, like viruses, bacteria, and protozoa, are microparasites, meaning they have intensity-independent pathology. You get one rabies virion, and you're going to have full-blown rabies. And in general, large parasites like worms and arthropods are macroparasites, meaning they have intensity-dependent pathology. You will never notice if you're infected with only 2 schistosome worms, but you will if you have 100. But size doesn't always correlate to whether you have intensity-dependent or intensity-independent pathology. And therefore, it doesn't always correlate to whether you're a micro or a macro parasite. Consider Gyrodactylus. This is a really important genus of monogenes that infect the skin and the gills of fishes. I already showed you some of their opistaptors. They tend to have really, really big anchor hooks, and typically 2 of them right in the center of the opistaptor, as you can see in this specimen. But that's not the coolest thing about Gyrodactylus. Unlike most other monogenes, Gyrodactylus does not produce eggs. It actually gives birth to live offspring. And they are able to reproduce asexually in a process called polyembryony, which allows them to rapidly build up large numbers on their host. Now, that might seem kind of quotidian to you at this point, right? Like, we know lots of things that can reproduce parthenogenically or asexually, and it doesn't seem like that far a stretch for flatworms. They're pretty rudimentary organisms. Lots of other flatworms do asexual reproduction. But this is even cooler than that because polyembryony isn't just any asexual reproduction. It's asexual reproduction where the mom has a baby inside of her when she's born, who has a baby inside of her, who has a baby inside of her. So this is like a Russian nesting doll parasite where each individual comes with another generation already inside of it. The key to seeing the nestedness is to look for the anchor hooks of that opistaptor. Check out the big circular opistaptor at the bottom of this diagram. See the 2 symmetrical anchor hooks in the middle? Every daughter and granddaughter will also have those, and they're the easiest things to see. So now look at the big shaded oval in the middle of the worm. Can you see the angry hooks folded away at the bottom of that oval? That oval is this worm's daughter, and the hooks you're seeing belong to the daughter's opistaptor. Now look inside the daughter. Can you see even smaller hooks folded away in there? Those hooks belong to the granddaughter, who is already developing inside the daughter, who is already developing inside the mom. Now that's a diagram, of course, so let's take a look at how this would appear under a microscope. I found this awesome photo on Reddit. You can see the hooks on the mom's opistaptor, and then clear as day, the hooks on the daughter and on the granddaughter. So we've got a Russian nesting doll of at least 3 generations that we can see in this one monogene. And that means that this mom's daughter is ready to pop out of her own daughter almost as soon as she's born. And that makes it possible for this parasite to build up very high numbers on the host really rapidly. For this reason, Gyrodactylus is a huge pest of aquaculture. Where you keep fish living in really dense conditions, Gyrodactylus does really well. Just imagine dropping a single Gyrodactylus into a net pen packed with salmon. Because they can reproduce asexually and very rapidly, within days, one worm could become thousands, and within months, all of your fish could be crawling with Gyrodactylus. This doesn't happen at low host density because the Gyrodactylus don't have an oncomycetium stage. They can't move great distances from one host to the next. But if those hosts are packed together, watch out. This highlights the important distinction between macroparasites and microparasites. Macroparasites are defined as parasites where the pathology is dependent on the number of colonizers, known as intensity-dependent pathology. With macroparasites, such as schistosomes, for instance, the pathology is dependent on the number of schistosomes that colonize the host. Macroparasites do not produce new adults within the individual host that the parent macroparasite is infecting, meaning pathology is dependent on the number of adults infecting the host. Think about the schistosomes. If you've got a pair of adult schistosomes in your circulatory system, their offspring don't go on to infect you. Their babies go on to infect a first intermediate host snail. So the pathology caused by these worms depends on how many of them you've got in your circulatory system. On the other hand, microparasites are parasites where the pathology is not dependent on the number of colonizers, known as intensity-independent pathology. In the case of microparasites, the offspring infect the parent's host. Think of COVID-19. All you need is one virion to instigate the entire pathology of COVID-19. It only takes one little infectious dose, and that can produce within the body of the host thousands, hundreds of thousands, millions of new virions to create the same pathology that you'd get if you had an enormous initial dose. It's easy to think of macroparasites as worms and microparasites as things like viruses, protozoa, and bacteria, right? But it's not the case that every worm is a macroparasite. And Gyrodactylus is a great example of a worm that is a microparasite because the severity of Gyrodactylus infections doesn't depend on the initial number of Gyrodactylus infecting or colonizing a particular host. The babies of one Gyrodactylus go on to infect the host that the parent is infecting, and therefore one colonizing Gyrodactylus can yield an overwhelming infection, same as a virus, and that makes them microparasites. So we've talked about monogene host specificity, monogene host tracking, and how the monogenes exemplify the difference between macroparasites and microparasites. That's it for the monogenes. In the next videos, we'll talk about the cestodes. I'll see you there.